On 12.5, we were talking about our expected value, and we were talking about this charity game, right? Looking at, first of all, what the expected payoff was, what the charity got out of the deal, and then what the expected payoff for the donor was. Okay? So that was a good example of how to use the idea of expected value. And we have another one here to get us started. So, Margaret has $10 to spend on game tickets for a charity fundraiser. Which game should she play to create a greater expected payoff for the charity? So, always read there, what is it we're looking for? Greater expected payoff, and this is for the charity. And note, what did she have? $10. Okay. Thoughts on where to go here? I guess take a moment here. What do we have? Game A, ticket costs $5. If you win, it's a prize of $2,000, and your chance of winning is 1/1000th of a chance. Very small chance. Or you can play game B, $10 ticket. If you win $50,000, but your chance of winning is 1/10,000th of a chance, so even less of a chance, which makes sense, right? Bigger pot, less of a chance of winning.
I'm spending $10.
Huh?
I'm spending $10.
Well, either way, we're spending the $10. So Patrick wants a chance to win the 50,000. Not that piddly little 2,000, huh? Yeah. Okay. So, game A. What do we know?
You can play it twice.
Okay, we can pay it twice. Now, what I'm going to suggest is that we figure out the outcome for once, and then we can just double that in the end. Does that make sense? So we can play it twice. We're talking about charity. So, what's the charity get out of the deal if we play game A? Each time we play it, they get what? $5. What do they risk losing? $2,000. What's their chance of losing $2,000? 0.001, yes? So, we're doing this for the charity, okay? It's not about what we get out of the deal, it's what the charity gets out of the deal. So the charity is going to get $5 is positive, right? And again, as I said, yes, we can play this game twice. We'll double the result in the end, okay? So they get $5, but they could lose $2,000. So what do I want to do here? We're going to, I put add, but what do we need to think about that $2,000? That is a negative in respect to the charity, yes? Because they could lose $2,000, and their chance of losing $2,000 is 0.001. Okay, does that make sense? Are we good with that? Now someone's doing the math out there, right? $5. At 1,000th chance they lose $2,000. What's this all equal out to be? In other words, what is 1,000th of 2,000? 2. That's a negative 2 then, right? So what do we know? 5 plus negative 2 is going to be 3. So each time we play game A, the charity gets, on average, $3 off of us, yes? What about game B? Okay. They're bringing in $10. And then what else do we have to consider?
Plus the negative 50,000.
Okay. They could lose 50,000, so that's going to be a negative 50,000. And the chances they lose that 50,000 is 1/10,000th, right? Bless you. So 1/10,000th of 50,000 is what? $5. You take that and subtract it from the $10 that you paid them, and you're at $5, yes? Now, I just wrote out individual games, yes? So what do we kind of already talk about with game A? With game A, what would you do?
Play it twice.
You would play it twice, right? Since we have $10 to spend, we would buy 2 tickets. And with 2 tickets, if I buy 2 tickets, what are they going to get out of me on average? They're getting $6. As opposed to game B. What do we know about game B? With $10, I can buy 1 ticket, and what are they getting out of me? $5. So, according to the numbers, which game should she play to create a greater expected payoff for the charity? No? Where's the charity going to get more money from us? Game A. Okay, because either way I'm paying $10. But game A, each time I play it, on average, they get $3. Okay? So we're looking at game A here. Because the tickets are cheaper and I can play it twice. Okay? So now if we think about it, if game A is a greater payoff for the charity, is Patrick right in wanting to play game B? Is that the better payoff for him? As the donor, it's the better payoff if we play game B, but that's not what the question was, right?
Must be that guy. Why does she care about how the charity get more money on? Does she want to?
Some people aren't about the winning, they're about, I want to donate the money.
Well, then yeah, just donate the money. Don't play the game. It's a lot easier.
And that's true. If she donates the money, the charity just gets a flat out $10, huh?
Or if you went 50,000, put half of it to the charity.
There we go.
And then immediately
Or
give
take it
them-
all day, get put it all in play.
Okay. Expected value, expected payoff. Are we getting the idea here? You have to take into account what it is you're paying out, what it is they're getting out of the deal. Okay, and that's where the probability comes into play. Okay, moving on. Along the same lines, using expected values to evaluate strategies. Let's look at this one. You're considering options for an auto insurance policy. The insurance company offers new car replacement insurance in the case your car is totaled. There is a 1% annual chance of the car being totaled. Which of the 2 plans has the lower expected cost? Okay. So we have an A and a B again, yes? And ultimately, we're looking for lower expected cost. Now, with that in mind, what do we know? Plan A, there is a $50 premium. Okay, premium being what you pay, gosh, however often they ask you to pay it, right? We wish a $50 premium. Maybe it's just to get that deductible. I don't know. And in that case, it's a $500 deductible. So if you have to use the insurance, you're going to pay $500. Plan B, it's a $60 premium. So you're paying a higher cost, but zero deductible. Okay? They fully cover it. Now, what other information do we have? There is a 1% annual chance of the car being totaled, which means there's a 1% annual chance that you're going to have to pay the deductible, right? So, which of the two plans has the lower expected cost? When we're talking lower expected cost, we're talking about which of the two plans benefits us more, right? Okay. So, what's the known cost that we have to pay no matter what? $50 or $60, right? So we're going to start with the idea of what I'm going to call the known cost. And then we're going to have to add on what? Okay, that deductible. And what it is that's the unknown, right? You don't know if you're going to use it or not. That's where the probability comes in. So I'm going to write it as the expected value of the unknown. Okay, that's how I kind of want to think about this. So on A, the known cost is a premium of $50. And if you guys can't tell, I take these problems straight from the book or, wherever I'm looking at my problems here. I really wish I knew. It just says it's premium. It doesn't say how often you pay it or what it's for exactly, but because I don't know how much you guys know, but car insurance, no, not that cheap. So if you pay the $50 premium, what's the expected value that we could have to pay? $500 deductible, but there's a 1% chance. So here we're going to say the $500 times 1% is 0.01. So what is 1% of 500? Five, right? 1% of 100 is 1. So 1% of 500 is 5. And 50 plus 5 is 55. Okay, what about B? The known cost on B is $60. You know you're paying that no matter what. What's the unknown? 0, because, officially, if I want to be official here, it's what? It is 1% of 0. But what is 1% of 0? That's 0. When you add it to 60, we are at 60. So, according to these numbers, which of these two plans has the lower expected cost? Plan A. Okay. Right there, Plan A. Now, in reality, they don't say it, so we can't use it. But that premium, is that probably more like a monthly premium or something?
Well,
I don't know.
It might be like every 2 weeks, because I know our insurance is not $50.
Oh, I know. So, okay. Regardless, we're going off of the information provided, right? That's what, Okay. Another insurance one. Okay. Zachary has 2 choices for dental insurance. Both cover routine expenses. He estimates there is a 25% chance he will need a crown costing $1,500, and that he will have no other non-routine expenses during the year. Which insurer has the lesser expected total cost per year? Okay, so what are we looking for? Lesser expected total cost. Okay, so we have Dentifix, $600 annual premium, annual deductible of $1,800. Okay, so premium, you pay that no matter what. Deductible, you pay if you have to use it. Okay, enamel, I don't know. $750 annual premium, you pay that no matter what. Deductible, $700. So, what are you doing? What do you know about Dentifix? Okay, there's a flat 600, paying that no matter what. And this one does say annual premium, yes? Annual being once a year. What else are we possibly paying?
1,800,
1,800, 25%. So we are paying the $1,800, but there's only a 25% chance he estimated that he's going to have to pay that, right? So what is 1,800? What is 25% of 1,800?
250.
That does say 1,800 there, yes?
Yeah.
Okay. Sorry, my notes are wrong here. My answer key is wrong. I used 1,500 in my notes, so I don't have the same number. It's all right. Okay. So what did you guys say it was?
450.
Okay, so 600, that's 450, so we're at 1,050. Okay. I don't know what I was doing. Okay, and what about enamel? Enamel? I don't know how to say that. I don't think that's how you spell enamel, so. What do we know? Fixed cost of $750. If he gets a crown, what's he paying? He's paying $700, and there is a 25% chance he pays that. So, 25% of 700, 175. And if we add that to 750, we are at 925. Okay. Which insurer has the lesser expected total cost per year?
Enamel.
Okay. Right there, folks. 925. Your better deal is the enamel. Okay. Okay. Got it? Okay. One last topic here. Okay. And this actually, it kind of works out well because this is a topic that I missed teaching you guys in person last week. And you had to figure this out a little bit online, using the video and everything. So on the last page, we're going to talk about binomial probability, which when we talked about binomial probability, we have this formula, okay? And that's where we're going back to, okay? This is that formula that I ran out of time to teach in class last Wednesday. So, there's your reminder. We're going to be talking about that formula. Now, look at the example here. According to the weather app on Talisha's smartphone, there is a 40% chance of rain for each of the 5 days of her vacation. How many rainy days should Talisha expect during her vacation? Okay. So the idea here is that each day has a 40% chance of rain. Okay? When we look at this, how many days should Talisha expect during her vacation? No days. 1 day. If we factor into the 40% chance each day, how many days is she looking at? Well, this is where our binomial probability formula comes in, because this was the probability. And if you recall, we talked about R and N. So we talked about, picking from N days and how many days you pick. And so in order to figure this one out, we're going to have to look at, okay, what is the probability that none of the 5 days have rain? And then 1 of the 5 days, 2 of the 5 days, all the way up to all 5 of the days. Okay, so we're going to look at probability of 0, 1, 2, 3, 4, 5, and then we're going to put those together in the end. Okay, so this is where you definitely need the calculators out. It'll be a good opportunity to practice. Okay, because I don't know how, if you guys looked at the notes and got this or not. So let's start with probability that 0 days rain. Okay, now probability that 0 days rain out of how many days? Out of 5, yes? So in this case, when we look at this, ways to get R successes in N trials. So ways to get 0 successes in 5 trials. So when we do this on this first one, I don't want to say this, okay? Your N is always going to be 5 because that's how many days we're going out of. Your R value is right here. Okay, your R value is what you're finding the probability of. Notice P of R. So P of R, NCR. So that's going to be 5 days, the combination of 5 days picked 0 at a time. So 5C0, that's this first piece of the formula. Okay, P raised to the R. What's our P is probability. What's our probability? There's a 40% chance. What form of that are we going to use? Okay, 0.40, or in other words, 0.4. And so we're going to use 0.4 raised to the R. What is R here? And that is 0 in this one. Times, right here, 1 minus P raised to the N minus R. So 1 minus P is going to be 1 minus 0.4 raised to the N minus R. Subtract those two numbers. 5 minus 0. Okay, guys. I strongly encourage everyone, grab your calculator. Let's practice. Make sure we know what we're doing here. Okay. Okay, 5C0. On my calculator, I can do 5. Probability button. Arrow over to NCR. So 5C0. Should I put parentheses around that? I don't think so. Well, because what I was going to try and do is say times 0.4 to the 0. Now, on this one, what is anything raised to the 0 power? 1. Okay, so in my brain, I can skip that. What is 1 minus 0.4? That's going to be 6, or 0.6, right? Raised to the 5th. So what I'm going to try and do, I may have messed this up, 0.6 raised to the 5th. And it agrees with my answer key. Okay, so NCR does not have to have parentheses around it. However, the other pieces I would put parentheses around it, I guess. So that is 0.0776. Well, okay, so that is a chance that none of the days are rainy. Is, yeah, like a 7.8% chance of rain. Now, that's a chance that 0 days are rainy. What are we looking at? We need to look at all the options here. Okay, because it's how many rainy days should Talisha expect. So that's probability that 0 days are rainy. Now, let's look at the probability that 1 day is rainy. So basically, what am I doing here? All my zeros become ones. So 5C1, 0.4 raised to the 1. Guys, what is 1 minus 0.4? It's going to be what every time? 0.6. Can I go ahead and fill it in as 0.6? It's going to be 0.6 every time. And this time it's going to be raised to the 5 minus 1, which I'm smart enough to know is 4. And I think you are too. So, 5, probability button, NCR, 1, times. Do I have to use parentheses or not? I'm going to try it. I think you might have to use parentheses. 0.4 to the first times 0.6 to the fourth. This could be a fail, so beware. No, actually, you don't have to use parentheses. That worked. Have you tried the calculators? What? I didn't either. I thought maybe you'd have to get the calculator to cooperate. Okay, keep going, guys. Probability of 2. 5C2. 4/10 raised to the second. And 6/10 raised to the 5 minus 2. Now, I will say, like, if you type in 5 minus 2 in parentheses, you would need parentheses around that. If you don't just go ahead and do the 5 minus 2 in your head, which is what I've been doing. And we got an answer for me?
3, 4, 5, 6.
Uh-huh. Wait, 3, 4, 5, 6. Okay, keep going. We're halfway there. Probability of 3. 5C3. 4/10 to the third. 6/10 to the 5 minus 3. You can also just go up and back up, and if you arrow up, just arrow over and change numbers. Like I could say, okay, that's 5C3 now. That's 0.4 to the third. That's 0.6 to the second. Your answer match my answer? 0.2304. Okay, 2 more. Probability of 4. 5 days, picked 4 at a time, times a 40% chance on each of those 4 days, and then times a 60% chance on 5 minus 4, so the remaining 1 day. Zero point 0.0768. Okay. Probability that all 5 days are rainy and she has a stinky vacation. No? No one wants rain every day. So, 4/10 raised to the power of 5. 6/10 raised to the power of 5 minus 5. So really, 5C5 is going to be 1. 0.6 says 0 is going to be 1. The only one that matters is 4/10⁵. 0.01024. Okay, guys. What we just did, we found the expected value at each of those days. Okay? We found the expected value at 0 days, or the probability at 0 days, the probability at 1 day, all the way up. We want to know how many rainy days should Talisha expect. So we are looking at expected value. Okay, to put this together, what's the probability that 0 days are rainy? So we're gonna, it's 0 days times the probability of 0.07776 plus, what's the probability that 1 day is rainy? 1 times 0.2592 plus, what's the probability that 2 days are rainy? 2 times 0.3456 plus 3 days times 0.2304 plus 4 days times 0.0768 and plus 5 days times 0.01024. Okay. Let's calculator after that, right? I know what I've written down. I don't remember exactly if I have this rounded or if it comes out exactly this, because I have a whole number written down.
Like the decimal place?
Yeah. Does it come out with decimals?
Yeah.
Okay. And I'm not surprised. I just... Wait, it does?
What's yours?
I must have typed something wrong then, 'cause mine just came out to be a whole number.
Yeah, mine. What's yours come out to be? No, it's not.
1.22. Oh, here's
What are we getting?
here's
Say it. You got a whole number. You're probably right. 2.
Okay, that's like,
Okay. As I said, I couldn't remember if I rounded to be 2 or if it came out to be a whole number of 2. If you didn't get 2, you probably hit a wrong button on the calculator, right? So, there's an expected value of 2, and what is that? We're expecting 2 rainy days. I shouldn't say we. Talisha is expecting 2 rainy days. Okay? Okay, guys. I know those take a lot. Okay? But that's an example of using your binomial probability formula. Okay? That's looking at 5 days. There's a 40% chance each day. That doesn't just mean there's a 40% chance all week. Okay? Okay. Hopefully that the formula, if you hadn't figured out the formula before now, you figured it out a little bit now. Okay? So, reminder, binomial distribution, probability distribution that shows probabilities of the outcomes of a binomial experiment. That's what we're looking at here. I have one more example. And this one, they gave us a chart. So I gave this problem to you second. So it's kind of already set up for us, though. A carnival game has 4 orange lights and 1 green light that flash rapidly, one at a time, in random order. When a player pushes a button, the game stops, leaving 1 light on. If the light is green, the player wins a prize. Complete the table, then determine the number of prizes the player can expect to win if the game is played 4 times. Okay, so Determine the number of prizes the player can expect to win. Right there, they're asking us to do expected value. Okay? Now, what was it? If the light is green, the player wins a prize, right? Okay. Well, okay, so we're looking at probability you get green light, yes? And when we look at green lights, or let me rephrase that, probability that we get a green light, and there's only, I'm trying to remember how this works. Okay, game is played 4 times. That's what it was. That's the part I overlooked. Too many 4s in this problem. Okay, so they play the 4 times. Out of those 4 times, is there the possibility you'll get 0 green lights? There's a possibility you would get 0 green lights, wouldn't there? Okay, and so that's this first example of pick in the 4 games, picked 0 at a time. So if we get no green lights, what's the probability of winning? Where's that 0.2 come from? What's the probability of winning? They didn't tell us the probability, but
20% because of more than the 5 lights.
how many total lights are there? 5. 4 orange, 1 green. When do we win? If that green light is picked, yes? So what's the chance of that green light being picked? Chance of the green light being picked is 1 out of 5. Hey, guess what 1 out of 5 is? That's 0.2. So there is your P. Now, if this is P, remember, where does 0.8 come from? That's 1 minus P. So if your probability of winning is 20%, what's your probability of losing? 80%. Because this would be 1 minus P, or in other words, 1 minus the 0.2. Okay, and then this is the 4 minus 0. Now, they've already done the first one for us. We have to fill in the next one. Okay, of the 4 times you play, what's the probability you get 1 green light? Well, what are we going to say here? Out of 4 chances, there is, we're looking at 1. What's the probability of winning? 2/10 to the 1. Because remember, it's, go back to your formula, it's P to the R. And then your chances of losing. So this is the 1 minus P. And this goes to what? It's N minus R, right? So it's 4 minus 1, which is 3. So 4C1 times 2/10 times 8/10 to the 3rd, essentially, which is? Okay. 0.4096 again. Okay, keep going. Now, chance that twice you'll have green light. So, combination of picking from 4 lights, or 4 times, 2 times winning. 2/10 probability of winning raised to the 2nd, raised to the R. 8/10 probability of losing. Well, it'd be 4 minus 2, which is 2. So 4C2, 0.2 to the 2, 0.8 to the 2 is 0.1536. Okay, finish it up. Now, out of 4 games, chance of winning 3 games. 2/10 to the 3rd, and 8/10 to the what? The 1st. You're catching on, yes? and 0 point something. That's all I got. 0.0256. Okay. 4C4, 2/10 to the 4th, and 8/10 to the 0. 0.0016. Okay. Number of prizes we can expect to win. Okay, what are these? These are the probability results. So, what are we going to do with this? Probability of winning 0 times. Oh, 0.4096. Okay. Add and multiply. You do end up with, and I will finish this up and write it down, 0.8. Okay, so you can win 8/10 of a prize. That's your probability. Okay, guys, I'm going to finish writing this out. 12.5 is out there and available.
But we didn't get the notes done.
Yes, we did. So, 0 times 0.4096. 1 times 0.4096. Plus 2 times 0.1536. Plus 3 times 0.0256. Plus 4 times 0.0016. And now we've officially completed the notes.
I was listening to